You can freely download this practical notebook from my website. From its home page, go to middle left and click Books and Notes. A new web page will open. Then download third book in PDF format. Experiment 15 on page 138 in the practical notebook. Left side of the same experiment.
Okay, good afternoon students. We are going to perform the experiment to study the variation of electric current with the intensity of light using photocell today. Apparatus in this experiment is photocell, microammeter, plug key and a source of light. Here we will use the source of light as electric lamp. Practical apparatus here, this is a photocell, this is electric lamp. The two terminals of this photocell, one is P type and other is N type. P terminal of photocell going to the positive terminal of microammeter. Negative terminal of microammeter is going to the plug key, and then the other terminal of plug key is going to the negative N type of photocell. Here we have photocell in this box. Its P type is this one. It is connected with the positive terminal of the microammeter. The other terminal, which is negative terminal of microammeter, that is going to the plug key. The other terminal of plug key, that is going to the N type of this photocell. Now students, you will see the procedure how we will perform this experiment. We will turn on the electric lamp and then we will move this electric lamp slowly towards the photocell. And you can see the reading in the microammeter that is changing. As you are decreasing the distance of the electric lamp from the photocell, the electric current, the magnitude of the electric current, that will increase, and you can observe this on the reading of the microammeter. Now we will turn this electric lamp on and we will move this electric lamp slowly towards the photocell. As we decrease the distance between the electric lamp and the photocell, the current will increase. You can see it from the microammeter. As I am moving this electric lamp towards the photocell, mean decreasing the distance, the current in the microammeter, that is increasing. So we will do this in steps. Now we will move this electric lamp towards the photocell. As distance is decreasing, the current will increase in the microammeter. You can see from the microammeter. We will change the distance between the electric lamp and the photocell in regular intervals, and we will note the corresponding values of the electric current from the microammeter. In this way we will have a 6 or 7 set of observation, and then we will plot the graph between the electric intensity and the current. The electric intensity would be taken along x-axis and current would be taken along y-axis. Now you can see this, here we have a plug key in order to make the circuit on and off. If we take out this plug key, the circuit will become off, and if you insert this plug key, the circuit will turn on and current will start flowing through the circuit. After taking the readings, 6-7 sets of readings of electric current and the distance between the electric lamp and photocell, we will plot the graph between electric intensity and current by taking electric intensity along x-axis and current along y-axis. Now here we know that electric intensity is inversely proportional to the square of the distance. So we will take here electric intensity as I directly proportional to 1 over d square. Now we will plot the graph here between 1 over d square and theta, correct. Since current and electric intensity, they are directly proportional to each other, so graph here will be a straight line like that. This would be the graph between electric intensity and electric current. Now we will plot the graph between intensity of light and electric current. As we know that electric intensity is inversely proportional to the square of the distance. So here this light intensity is directly proportional to the current. So we will take here light intensity along x-axis and current along y-axis. Since they are directly proportional to each other, so graph will be a straight line as shown in the figure. As we know that the light intensity, that is inversely proportional to the square of the distance between the electric lamp and photocell. So here I is directly proportional to 1 over d square. We also know that electric current is directly proportional to the light intensity. So here we will plot a graph between the electric current and the light intensity. Now we will take the light intensity along x-axis and the electric current along y-axis. So we plot the graph between theta and I. Since theta and I, they are directly proportional to each other, so we will get a straight line graph here. That shows that when the light intensity will increase, the current will also increase and vice versa.
You can look actual practical graph on page 108 in the notebook.
Now first of all, you need to check whether the electric lamp is turned on or not. Now here we turn on the electric lamp. Now in the second step, you need to check from where you will move the electric lamp so that you should get the value of the current in the galvanometer. So that is the second point here. Now you need to also check that the ammeter reading should not go out of scale. So this final distance from the distance of the electric lamp from the photocell, that must be noted also. Now in third place here, you need to check first that which terminal of the photocell is P type and which terminal is N type, because you will connect here the P type terminal of the photocell with the positive terminal of the micro ammeter and N type terminal with the negative terminal of the micro ammeter. Otherwise you will get the reading in the micro ammeter in the wrong side, as if this is connected, you can see here when this N type of the photocell is connected with the positive terminal of the micro ammeter and the P type is connected with the negative terminal of the micro ammeter, the deflection in the micro ammeter, that is reversed. So this is not the correct method. So you need to check first these terminals here so that you can get the correct reading in the ammeter and you can note it. Like in the last step, you must also check whether this plug key is on or off. Sometimes the plug key remains off and you say that reading is not, you are not getting the reading in the ammeter. So first you need to check here whether the plug key has turned on or not. So these are the steps which you will keep in mind in order to perform this experiment correctly. Now here we will check that from which point, initial point, the reading starts in the micro ammeter. Here, this is the point where you can see the reading in the micro ammeter. In next step, you will check the final distance of the electric lamp from the photocell so that the reading in the microammeter should not overshoot. So these 2 points must be marked on the meter grid. Now next source of error may be, here you need to check the P-type and N-type terminals of the photocell, because P-type is connected with the positive terminal of the microammeter and N-type should be connected to the negative terminal of the battery. Otherwise, you will not get the correct reading in the microammeter. Here you can see the P-type is connected with the positive terminal of the ammeter and N-type is connected with the negative terminal of this. And you can see you are getting the direction of the needle of the microammeter in proper way. If you will change these terminals, you connect the N-type of photocell with positive terminal and the P-type with the negative terminal of this microammeter. You can see here the direction of the deflection of the needle has reverse. This is not a correct method, so you need to check this. We should also check whether the plug key is on or off. Sometimes the plug key remains off and we say that current is not coming in the microammeter. So we need to first check this whether the plug key has been turned on or it is off. So before starting the experiment, you must plug on this key.
You can take this objective physics practicals from Ilmi Book Depot, Urdu Bazaar, Lahore, or you can download directly from my website. Your readings may be different from these readings. Check these readings as a reference. Thank you.